Assalamualaikum. Today our group will explain thoroughly about introduction to the forward-backward method. Before we getting any further, we will start it with introducing our group members. Firstly, me myself, Mahadhir Hamzi.
I'm Nooranisyah binti Shamsi.
Hi, my name is Nur Hidayu binti Rosli.
My name is Nur Dalilah binti Baharudin.
So, what is proof? In mathematics, a statement is regarded as a proposition or sentence that can be either be true or false. A proof itself is a convincing argument that can be expressed in the language of mathematics. Choosing hypothesis, which is A, and conclusion, B, is the first stage in creating proof. Meanwhile, hypothesis and conclusion. By putting the implication in the form of if A, then B, it is much simpler to determine if a statement is true or false while completing proof. In case the implications are not written in the specific form, thus, everything that is assumed to be true is A, which is the hypothesis. The conclusion of the statement or statement that need to be proven is a B, which is the conclusion itself. For example, if there a question asks for if n is an odd integer, the n square is an odd integer. So now the hypothesis will be n is an odd integer and the conclusion will be n square is odd integer.
So here the first example for the forward-backward method. If A and B are odd integer, then A plus B is even and AB is odd. Now I will explain the solution for this question step by step. Firstly, as in my case, we need to choose the hypothesis and also conclusion, and we need to label it as A and B respectively. Then we're gonna start writing with B1 as backward process, and we have to write the key question of B. The definition of an even and odd number, which is A plus B equal to 2k and AB equal to 2k plus 1 for some integer k. Next, we will jump to the forward process as we don't have any key equation for B1. To start with the forward process, we will write A equal to 2j plus 1 for some integer j and B equal to 2I plus 1 for some integer I as A1 and A2 respectively. Furthermore, in A3, we will have to substitute the variable of A and B from A1 and A2 as shown. For the last step, we are going to factorize and also substitute the variable as written in A form. Therefore, B1 is proven. We are not yet finished. We still have to write the condensed proof. Condensed proof is just our explanation regarding our work using mathematical language. So, the condensed proof for this question should look something like this. Given A and B are odd integers, prove that A plus B is even and AB is odd. Since A is odd, then there exists an integer j such that A equal to 2j plus 1, and since B is odd, there exists an integer I such that B equal to 2I plus 1. Therefore, A plus B equal to 2 in bracket j plus I plus 1 and AB equal to 2 in bracket 2ji plus j plus I close bracket and 1 and plus 1. Since j, I, and 1 are integers, their sum is an integer. So A plus B equal to 2k and AB equal to 2k plus 1, where k equal to j plus I plus 1 or k equal to 2ji plus j plus I. Hence, A plus B is even and AB is odd. After we finish writing the condensed proof, we must put a small bar after the full stop as we show that it is the end of the condensed proof. So that's how to answer this question using the forward-backward method.
For the next question for forward backward is, if s and t are two consecutive odd integers, then to divide s squared plus t squared. First step is we must recognize A and B statement. For this question, A statement is S and T are two consecutive odd integer or hypotenuse. For B is to divide S squared plus T squared or conclusion. We must know the key question. The key question for this question is, how can we show that to divide S squared plus T squared? Using backward process, the answer is if we can show that S squared plus T squared twice some integers. So B1 is S squared plus T squared is equal to P for some integers P. A1 is we let S equal to A plus 1 and T equal to A plus 3 for some integers A. Next step is A2. We substitute the value we get on A1 into S squared plus T squared. So we get the answer is 2 bracket 4A squared plus 8A plus 5 equal to 2P, where P is equal to 4A squared plus 8A plus 5. So we get the A2 equivalence to B1. Next, I will explain about the condensed proof. Given S and T are two consecutive odd integers, prove that to divide S squared plus T squared. Since S is odd, then there exists an integer such that S equal to A plus 1. And since T is consecutive odd integer from S, exists an integer A such that T equal to A plus 3. Therefore, S squared plus T squared equal to bracket 4A squared plus 8A plus 5. Since A is integer, so S squared plus T squared equal to P, where P equal 4A squared plus 8A plus 5. Hence, to divide S squared plus T squared. Thank you.
For the next example, the question is like this. If m is an even integer and n is an odd integer, then m plus n is odd. So we need to find our a. In order to find a, we need to find the hypothesis from the statement. So our a would be m is an even integer and n is an odd integer. Next, we need to find the b. So in order to find b, we need to find the conclusion from the statement. So our b would be m plus n is odd. So we need to do the backward process. In order to do backward process, we need to find the definition of an odd number. So our b1 would be m plus n equals to 2p plus 1 for some integers p. And now we're going to proceed to our forward method, where we'll get our a1. We need to find the definition of an even number since m is an even integer. So our a1 would be m equals to 2k for some integers k. Next, we need to do the same thing for n, but instead we need to find the definition of an odd number. So our a2 would be n equals to 2s plus 1 for some integers s. Now, we need to combine all the new equation that we found. So our a3 would be m plus n equals to 2k plus 2s plus 1. And then we will factorize it, and then we will get our a4. So our a4 would be 2 in the bracket k plus s close bracket plus 1. And we need to compare it to our conclusion. So our a5 would be m plus n equals to 2 in the bracket k plus s close bracket plus 1 equals to 2p plus 1, where p equals to k plus s. And that shows that our b1 is proven. So our condensed proof is like this. Given that m is even and n is odd, therefore m is equals to 2k for some integers k, and n equals to 2s plus 1 for some integers s. Therefore, m plus n equals to 2 in the bracket k plus s close bracket plus 1 equals to 2p plus 1, where p equals to k plus s.
In conclusion, in this video, we've shown 3 examples on how to apply the forward-backward method the right way. We hope these explanations help you to understand the method clearer. It is the end of the video. Thank you for your attention.